Hello everyone! Consider the following equation. Our goal is to find all integer values of a for which this rational equation has integer solutions for x. First, we need to set our restrictions. Since denominators cannot be 0, x cannot be equal to 2 or 6. Now let's clear the fractions by cross-multiplying. This gives us x minus 1 times x minus 6 equals x minus 2 times x minus a. Next, let's expand both sides. On the left, we get x squared minus 7x plus 6. On the right, it expands to x squared minus, open parenthesis, 2 plus a, close parenthesis, times x plus 2a. Notice that x squared cancels out from both sides. Now, if we move all the x terms to the left and group them together, our equation simplifies nicely to open parenthesis, a minus 5, close parenthesis, times x equals 2a minus 6. Now notice that if a equals 5, the equation becomes 0x equals 4, which is impossible. So a must be different than 5. Since a is not 5, we can safely divide both sides by a minus 5 to get x equals 2a minus 6 over a minus 5. We can express the numerator as 2 times, open parentheses, a minus 5, close parentheses, plus 4. Splitting the fraction gives us x equals 2 plus 4 over a minus 5. Now, for x to be an integer, the fraction 4 over a minus 5 must also be an integer. This means that a minus 5 has to be a divisor of 4. So the possible values for a minus 5 are plus or minus 1, plus or minus 2, and plus or minus 4. To make things clear, let's look at this table. For each possible value of a minus 5, we can easily find the corresponding values of a and x. But take a close look at what happens when a equals 6. The corresponding value for x turns out to be 6 as well. However, remember our initial restrictions? X cannot be equal to 6, so this solution must be rejected. Therefore, after excluding that value, the only valid integer values for a are 1, 3, 4, 7, and 9. And that's our final answer.